Hello everyone, I am welcoming you all once again to this channel. Today I am going to make a video on this VESTA software where we will see how to create a slab using this software. And here I am interested in creating a slab for this particular lattice, which is a cubic lattice along the 110 direction. So before creating a slab we need to learn how to create a plane. So if you want to learn that, I have made some previous videos on that. Also in this video also we will start from very beginning. So first I am going to create the supercell of this cell. For that I will be using this transformation matrix, and here our supercell is created. Now you can see that this is the supercell and the lattice plane we want to create is 110. So done. So this is the plane, as you can see this is the 110 plane. Now actually slab formation means we need to have a particular volume which will be confined among certain set of planes. So for that I am going to make a parallel plane which will be parallel to this particular plane. So every time while creating a parallel plane we need to keep this periodicity thing in our mind. So this is the atom FeCN6 group. Okay, so for that the next periodicity I can have over here along this line. So I am going to choose 3 such atoms. This is one atom, this is two, and this is the third atom. So using these 3 atoms I will create a new plane. So new one. So calculate the best plane for the selected atoms. Done. Then okay, so now deselect those atoms. Okay, so you see that this is the 2 parallel planes and which are also serving as 110. You see this is 110 and this is also 110, so both of them are parallel to each other. Now done. Next part is to create a plane which will be perpendicular to this 110 planes. Okay, so here also I am going to choose the atoms, this one, and this one, and I will again create a plane with the selected atoms, and I am changing the color so that it will be visible distinguishably. Okay, so now it is done. Similarly another plane which will be parallel to this red color one, also we need to have the maintained periodicity. So here I can choose a plane pass through this line, these atoms. Okay, so here for that I am going to choose this atom, and this atom. Let's go again, do the same thing. Selected atom plane, done. Deselect those atoms. Okay, so it is done now. So while you are selecting and deselecting atom, make sure that when you are selecting new atoms, if some other selected atoms will be present, then it might visible some other different planes which you don't require. So be very careful while selecting and deselecting those atoms. So after creating the plane we need to simply deselect those previously selected atoms. Okay, now done. So the next part is what? In the next part we need to create another set of plane which will be perpendicular to both of these planes. And why we need that? We need those because a slab is nothing but a 3-dimensional structure where we need at least 3 vectors like A, B and C vector, which will represent the different like the box size. The box size of the slab will be determined by these 3 vectors. So for that we need to have another plane, another set of parallel plane which will be perpendicular to both of these planes. Okay, so for that simply I am going to create another plane can choose that plane using these three atoms, 1, 2 and 3. So let's go and edit lattice plane, new one, selected atoms, change the plane color, green one. Okay, so now you see that another plane is done. I'm quickly I'm creating the parallel plane of the same one. So this one, and this one. Let's go and edit lattice planes, new, selected atoms. Okay, done. So now you can also check that this has also maintained periodicity. So here we have taken this FeCN6 group, FeN6 group, and here it is also FeN6. That means this is also periodic. Now you can have a look that here we have created such planes where we have a confined position of volume. So this portion is confining certain volume and having three such vectors like A, B and C something. And now the next part is to have those three vector accurately, we can delete some unnecessary atoms. So I am going to select those unnecessary atoms which are present out of this particular confined region. Simply select, delete, done. So next this side also simply select, delete, done. This side also, and also we need to be very careful that we are not deleting any boundary atoms, right? So here some extra atoms are also present. I am deleting those by selecting, and here we can delete, done. And next is I am rotating this with yes, this side and that side we have some remaining atoms. Simply select and delete. Here also simply select and delete. So you can see that this is done. Now we have only those atoms which are confined among this particular region. Okay, now next one is, let me first show you that whether these planes are perpendicular and parallel to each other or not. You see, so here in the first case we had the plane as 1 1 0, then we had the plane minus 1 1 and 0, then we had 0 0 1 plane. Now if I will multiply this, like we know that the formula to find out the angle between two planes is nothing but cos theta equal to a1 b1 plus a1 a2 plus b1 b2 plus c1 c2 divided by a1 square plus b1 square plus c1 square square root and a2 square plus b2 square plus c2 square square root. Okay, so here simply if I am multiplying 1 with minus 1, so this is 1 minus 1 and 1 with 1, this is my plus 1, so minus 1 plus 1, and this is 0 and 0, so this is 0, so the numerator becomes 0. That means cos theta is 0, that means theta is 90 degrees. So simple. So here also minus 1 0 is 0, 1 and 0 is 0, and 0 and 1 is 0. So all the numerator values are here 0, so we don't need to find anything else here. So this confirm that all the planes are perpendicular to each other. So done. Next is the initial plane we have considered as blue color. So the area, so the vector which will be confined between this blue color plane, so the vector will be this one, this to this, between these two atoms will be our z axis, and any other like other values we can took as it, like no issue, in no such constraint among that. But the first plane that we have chosen should represent our z axis, like the c vector value. And if I can take these two atomic, like the distance between these two atoms as a vector or b vector, no issue. So this I can choose as a, which will the difference is 7.189, and this side here to here I will choose as my b vector, so that vector is 10.16250. Okay, so this way we will choose. So simply what we will do, we will choose any atom as a origin. So here for the simplicity I am choosing this atom as a origin, and we will write the coordinates for all the three vectors. So one is the origin, one is the a1, b1 and c1, then we will write the coordinates, then we will write the transformation matrix, and simply we will transform our matrix. So let's go and do that. So here I am going to write the origin vector. So the origin vector is nothing but 0 0.25, 0 0.65 and 0 0.75. So here let me write 0 0.2500, then 0 0.6500, then 0 0.7500. Done. Next is this A vector. So this atom I will choose. So this atomic position is 0 0.500. So all these atomic positions are in direct coordinate values. So those values only I am writing, and 0 0.7500. Next is this B1 vector. So B1 vector is the behind vector. Okay, so the vector along this side. So this one. So this is nothing but 0 0.2500 and 0 0.6500 and 0 0.2500. Done. Next one is the last one, like our Z vector. So the Z vector is here to here. So this atomic position we required. So this is 0 0.500 and 0 0.900 and 0 0.7. Okay, so this is done. Now to get that vector, what we will do, so a1 so 0 to a1 will represent our a vector, 0 to b1 will represent our b vector, and 0 to c will represent our c vector. So I will take the difference between this atom and with origin, and I will put those values in this transformation matrix. So 0.50 minus 0.25 is nothing but 0.25. Then 0.40 minus 0.65 is nothing but minus 0.25, and then 0.75 minus 0.75 is 0.000. This one is 25 minus 25, so this is 0.00. Then 65 minus 65 0.00. Then this one is 25 minus 75 is minus 0.50. Done. Then this c vector, then 0.5 minus 0.25 is nothing but 0.25. Then this is 0.90 minus 0.65 is 0.25. Then this is 75 minus 0.75, so this is 0.00. So now this entire matrix is nothing but our transformation matrix. So simply what we will do now, let's go here. I am going to open the same Postcard file again, which we have chosen to create the slab. Now again let's repeat the same thing of doing this transformation of this to a supercell 2 2 and 2. So okay, then yes, okay, so apply. So done. So now this is our supercell. Now we need to create a slab of this supercell using this particular transformation matrix. Okay, so I'm going to edit, then unit cell. Here before going to make the slab, we need to remove the symmetry. So here I have removed the symmetry. So apply, then okay. So the symmetry is removed now. Let's now go to the unit cell and the transform. Here on the transformation matrix I will put these values 0.25, then here 0.25, then here minus 0.25, then here 0, and here 0.25, and here minus 0.5, and here 0. So this is the transformation matrix. We can match it. 25 minus 25 0, 0 0 minus 2 minus 5, 25 25 0. Done. Now click on OK, then yes, then apply, then OK. Now you see this is the slab along 1 1 0 plane. Now you see the Okay, one thing I can do here, I can open the unit cell. So you see, this was the unit cell and this is now the lattice, like the slab that we have created along 110 direction. Okay, so you can see the difference. And also if you want to match, so you can match the axis values of this slab and we will get it as exactly that much value. You see, here to here is our a vector, the a vector value is 7.1859, and here to here is our this is our z vector, that is 7.1895, and here to here is our b vector, that is 10.16. so exactly same value we have replicated, and replicated whatever we have cut bit from this particular three plane, like the volume between these three planes, and which is replicated to this particular cell, and simply you can save the file. So export data, so I am saving it to my desktop as postcard slab, and I will save it to my bas postcard. You can save or you can simply save to xyz, no issue. So I'm saving it to bas postcard and save it. Okay, so let's check. So this is the postcard I have saved now. So you see the postcard file is opened here, same thing. And if you will open that in your terminal, so cd I'm going to desktop vi postcard, so you can see that some more atoms are present over here. So these are nothing but the duplicated. You can see that 100, this particular portion is repeated so many times. So for that you can use simply PyMatGen and to remove that something called overlapped atoms. So that position you can simply remove, which is just a 4-5 line code. And this way when I have created, I have done like this. And if you found this helpful, you can go forward with this. Okay, so this much for today's section. I hope all of you have understood, and thank you all. Bye bye.